Now let's see how the files can be shared. In general, whenever people are working on some projects, they would like to share some files. So if a person has written a program, then some other person, the teammate, might want to use the same program. In that case, he cannot ask the other person to email him or send him via some other means. So if both the users are using the same, let us say, the system, and if both of them are working on the same project, then it is obviously important that they have to share some files. Now how to share files is, there are two approaches. Simply there are two approaches. Let us assume that we have a tree type structure. This is the root directory, and then we have two users. Let us say this is user 1 and then this is user 2. We have two users, and now assume that both of them have to share a file, just a file. Now what can they do? One thing is, we can create two copies of the file and then put them in both the directories like this. One copy file 1 and the same copy, the same file, the second copy. Both of them are copies. Now this is the simplest way in which you can share a file between two users. But do you see any problem there? The problem of course is, how do you update the files? Let us say this user has updated this copy, then our operating system in this case has to have the code to check whether a file has been updated, and in that case the second copy also has to be updated. Now it is going to introduce lot of complexity, in the sense, whenever any file has been updated, operating system should check if there is a copy, whether it is being shared by someone else, and it has to update it. Now operating system doesn't want to get into all these things, isn't it? As an operating system designer, we don't want to get into all this trouble. That is why this approach of file sharing, even though it is simple, right, implementation is not that simple, even though the concept is simple, since there are a lot of complexities involved in implementation, no one is following it. So what is the other way? The simplest way is, have only one copy of the file, but then let many people point to it like this. We are having only one copy of the file. Even though we have only one copy of the file, we'll have many people pointing to it like this. So how is it possible? Simple, just see this. Now I'll just take the directory level. Let us say this is the root directory, and the root directory is having many entries, and each entry, assume that, is pointing to the user level directory. Now this particular entry is pointing to a user level directory. Here there is a user and it is his directory. Now this is also going to have many entries, and in general these entries will point either to a subdirectory or to the files directly. Let us say this is the user number 1 directory, the directory of user number 1. Now this particular entry can point to a file. Assume that this is the file f1, that is what it is pointing to. Now from the root there is the directory of the second user. This is the user level directory of user 2, and now it is going to have many entries. Now one of the entry can just be a pointer to already existing file. Got it? And this concept is also sometimes called as a link. This is called as a link in some of the operating systems, like Linux. In Linux we implement this concept using something called as a link. So we have only one copy of the file and many people can share it. It is not that always many people should share it. Sometimes what happens is, there might be a program which is actually used by only one user, but then it might be required in two different projects, right? Then what can we do? Then both the project directories can point to this file. So what I mean to say is, even though here there are two users are sharing the same file, we can have a different organization in which a single user, sometimes let us say this is user 1, he is working on two projects. This is project 1 and this is project 2, and now this directory is containing all the files that are related to project 1. Now one of the file, assume that one of the file is required in the other project as well. Let us say this is program 1. Now program 1 is required by the other project as well. In this case, what happens is the other directory can simply create a link using which we can point it. Now if you look at this structure, either this structure or this structure, this one or this one, you cannot call it as a tree. Even though the underlying concept is simply a tree, here it is not called as a tree. There is a cycle, but then it is not actually a cycle because it is directed like this, isn't it? So it is not a cycle. So it is called as acyclic graph directory. Whatever we discussed now is called as acyclic graph. Now using the links, the file sharing has been implemented in operating systems like Unix, and MS-DOS is not using any of these. Even though we are not talking about the case studies, since we got here, you might have heard about the links, symbolic links and hard links in case of Unix. Even though we are not going to talk about them in detail, generally this is the concept. So they are using this acyclic graph. Now there are certain problems using these acyclic graphs. So one problem is how to deal with the file deletion. Now assume that this file has been deleted by user 1, which means the entry which is present in this directory will be deleted. Now what happens? The space allocated to this file will be emptied, but then this pointer will still be pointing to the same file. It is called as a dangling pointer kind of problem, isn't it? Therefore, the operating system implementation should take care of all these difficulties. Even though this is simple to discuss, implementation is going to have a lot of problems. One is how are you going to keep track of file deletions, right? And the other one is how are you going to list all the files. Sometimes what happens is, see, if you look at this problem, the problem is a same file may have different path names. The reason is you can access this file by using this path, as well as you can access this file by using this path. In case if many pointers, many links are pointing to the same file, then there will be lot of path names to the same file. Then what happens is whenever you try to list down all the files present in our let us say file system, then you might end up listing the same file many times. So just to avoid that problem, so we can improve the entries. Let us say we can distinguish the entries between what is the original entry of the file and what is a link. We can have some indication there, and whenever you are traversing the file system, whenever you come across any pointer, you can stop it. But then how can you delete a file? So in Linux, what Linux has done is it has done some clever implementation. So initially what people thought of is whenever there is a file, let us say there is a file F1. See, one more thing, it is not just that files are being shared. You can even share a directory. Let us say a directory, a lot of files are required by 2 users. Then the simple way of sharing them is you put all the files in a directory and then share the directory between 2 users. Therefore, these links can be created either for the file or for a directory. Just remember that, keep it in mind. But now when I am explaining, I'll just be talking about the files, but both of them can be done. We can either share a subdirectory or files. Now one way how to keep track of deletions is, see, I think you got the problem, right? So whenever you delete this file, what happens to all the entries which are pointing to this file? That is the question. Now how to solve it is, earlier what people thought of is whenever a file is being created, let us keep a data structure which will indicate all the references to the file. Like there is a reference from U2, let us say there is a reference from U3 also, user 3. Now you are supposed to put all the references here, the links either absolute links or relative links, right? But the problem is by keeping all the links, the data structure itself might have to grow very large if the number of links pointing to a file is too many, right? Then how to solve the problem is, instead of having all the links written over here, don't write the links, just have a counter for every file, counting how many links are pointing to this particular file, right? So let us say for this file f1, there is this one is directly there, and also there is a one pointer here and one pointer here, right? So you can have initially the counter as 3. Now what this Unix does is, or in general one of the implementations, what they can do is, whenever a file has to be deleted, don't delete it until all the references have been deleted, which means until all these 3 pointers have been deleted, don't delete the file. I think you got the problem, right? See, the problem is, there is a file and now many people are having links to this, which means from many directories there are some links to the file. Now if you directly delete the file, because one of the link is asking it to delete it, one of the user is trying to delete it, then all the remaining might become dangling pointers. Then there are 2 ways to solve it. One way to solve it is, whenever we refer to this link next time, you can find out that there is no file existing there, because that particular file has been deleted, and then you can remove it later. Otherwise, the second way of implementation is, don't delete the file immediately, just try to have the file till all the pointers have been deleted. So how to implement that? In not to implement it, you should have a flexibility there. So the flexibility is, have a counter which will contain all the references to the file, and in case if all the references have been deleted, then only you delete the file, right? And Unix is going to follow this approach. Unix is actually following this approach. What is the approach? It is going to have a counter, and whenever this counter becomes 0, then only a file will be deleted, otherwise the file will not be deleted. Got it? And anyway, DOS is not having any file sharing. So that is the point, concept behind acyclic graphs. And acyclic graphs is nothing but a kind of tree only. Only thing is, it is having this kind of links, so which will just spoil the tree structure. That is why we are calling it as a acyclic graph. In fact, tree is also a directed acyclic graph, isn't it? But then here you are having this kind of sharing links. That is why it is specially called as acyclic graph. Okay, fine.